Hello, welcome to this video. I'm PDS the tutor. In this video, we'll be looking at 2017 November paper 2 question 3. Sorry, question 2A and B. If you have the question paper, please have it. We have a question that says a box of chalk contains 5 white. So we have 5. Let white stand for W. Then you have blue. Let it stand for B, which is 4. And yellow, let it stand for Y, which is 3. Then says a piece of chalk is selected at random on the box and is not replaced. A second piece of chalk is then selected. So this is without replacement. Then draw a tree diagram to show all the possible outcomes. We have 3 colors. So we are going to have 3 possible branches. We're going to have this. So let this one be for white, this one for blue, one be for yellow. Then we're also going to have something like this, since there are 2 selections. Like that. So this will be white, this will be what? Blue, this will be yellow, this will be what? White, this will be white, this will be blue, this will be yellow, this will be white, this will be blue, this will be yellow. So we assume that we picked white and white. So what happens if we assume that we picked white and white? White is 5. So, and the total of pens here is 12. So white will be 5 over 12 in the first selection. Blue will be 4 over 12. While yellow will be 3 over 12. Like that. Now if you pick white and white, what happens? White will reduce by 1. So now if white reduces by 1, that means even the total in the second selection is going to reduce by 1. You're going to have a total of 11 chalks now. So we're going to have 11 chalks. So we have 5. So we are going to have, since if we pick white and white, so white reduced by 1, we're going to have 4, but over 11. But if you pick white and blue, it's not the same. If you pick white, that's the first selection. If you pick blue, blue has also its first selection. So blue still remains the same way it is, but the total will change. Blue still remains 4 here. To still remain 4, but it will be over 11. Then, what if you pick white and yellow? If you pick white and yellow, yellow will still remain the same because that's its first selection. 3 but over 11. So I can write here 3 over 11. Then let's come to B. If you pick B, which is blue and white, white will still remain the same, 5 but over 11, because now this is the first selection for white. But if you pick blue and blue, what happens if you pick blue and blue? If you pick blue and blue, blue reduced by 1. So we're going to have 3 but over 11. Then if you pick blue and yellow, yellow will still remain the same because this is the first selection for yellow, which is 3 over but over 11. Then if we have yellow here, we have yellow here, then we pick what? White. So it's called that white will remain the same. White will still remain the same, which is 5 over 11. But if you pick yellow and blue, blue still remain the same, the way it is in the first total, which is 4 over 11. Then, but if you pick yellow and yellow, yellow reduced by 1. So yellow will be 2 over 11. Then here it says the possible outcomes there. How can you write the possible outcomes? Possible outcomes. So outcomes. So the possible outcomes is WW. It's white and white, which is WW. Then we also have white blue. We also have white and yellow. We also have blue and white. Also have BB. Also have BY. Also have YW. Then we have YB. Then we have YY. So these are the possible outcomes when they say write the possible outcomes. And we have 2 that says find the probability of selecting pieces of chalk of the same color. So if you have to choose pieces of the same color, we are saying that can be white white, or that can be blue blue, or that can be yellow yellow. So we have 2 options. So it will be for white white, we get this, we multiply by this, we add plus BB, we get this, multiply by this, plus this by this. So confirm when you multiply this, add it to when you multiply this, then add your answer to when you multiply these two, and confirm that your answer is 19 over 66. Confirm that your answer is 19 over 66. We have question B that says, in the diagram below, you have OP, 2P, you can see it there. Then you have OQ, you can see it there. Then you have PX, which is the ratio to XQ, which is 1 to 2. So PX is there, then XQ is there. So before we go anywhere, we need to write the ratio. The ratio says PX to XQ, which is 1 to 2. Saying 1 to 2. This means PX and PQ, they are all on which line? They are all on line PQ. So this means PX is equal to 1 over the total ratio here is 3 over 3 of which line? Of line PQ. Also XQ is a line which is 2 over 3 of which line? Of line PQ. This is what this statement means. Now we know what, so I can just write here PX is equal to 1 over 3 of PQ, and XQ is equal to 2 over 3 of PQ. So I can erase this part. Now they are saying express PQ, find PQ. PQ means how can you move from P to reach Q apart from moving PQ like that. So you can move from P to O, then you move from O to Q, you still reach Q. So PQ is equal to PO, okay, plus what? OQ. Now when we look at PO, PO is in the opposite direction of OP. So PO is the same as negative 2P plus, that's 4, then Q. So this is the same as 4Q minus 2P. Then we have px. How can we find px? Now remember, px is this. Px is 1 over 3 of pq, right? And pq is 4q minus 2p, which is the same as 4q over 3 minus 2p over 3. That's px. Then we have ox. Ox means, remember, ox is here. Now how can we move from o to x without using ox? We can move from op to px, right? Yes. So we have op plus px. op is 2p, remember, and px we just found that it's this. It's 4q over 3 minus 2p over 3. We can now work out this and correct the like terms. So we have 2p minus 2p over 3. This is 2. We have minus, so plus here, plus 4q over 3. So when you work out, you are going to get, here you find the common denominator, which is 3. 1 into 3, you get 6p. Here you get 2p. So 6p minus 2p, you get 4p here, over 3, plus 4q over 3. So this is what we call ox. And we have 2 that says, given that oc is equal to h or x. Now h there, then ox is what that we found there, which is 4p over 3 plus 4q over 3. Then when we expand or distribute h throughout, we are going to have 4 hp over 3 plus 4 hq over 3. This is what OC is. And I'm saying, show that CQ is equal to this. Don't worry about what we've given it. We are just proving that CQ is equal to this. But in short, you have to find CQ and show that it's equal to this. So CQ, how can we find CQ in this case? So CQ, remember where CQ is? CQ is here. How can we move from C and reach Q? We can move CO, then O what? Or Q. So CO plus O what? Or Q. So CO plus OQ, like that. Then what happens? We have CO. Now remember, we have OC, not CO. So CO, it will be the opposite of OC. So I'm going to introduce negative here. We're going to have negative 4 HP over what? Over 3 minus 4 HQ over 3. This is what we have as CO. Plus OQ is just 4. Then Q. And from there we know that we can collect the like terms. So we have this. Let me just do this. We have this part here. Okay. Then we have also this part here. So from here you can see that this and this, there's Q here and there's also Q here. They're like terms, right? And since they're like terms, we know what to do. So we can just factorize here and keep the other value. So we have negative 4 HP over 3. Then when you factorize here, what is common? What is common is Q and 4. So this will be, we take out 4 so that it's the same as this part here. So we take out 4. So we have let's say positive 4 All right, then we maintain negative h over 3 plus 1, then we take q out this side. We're taking q because that's what you have denoted there, and when you take q, remember that you've taken 4q, and here we remain with 1, and here you just remain with h. And from there I can even see that it's actually shown that those two are equal. You can see there's this part here which is the same as there. There's now this part here which is the same as there. Just swap this, comes here where the other one goes there. Alright, so thank you for joining me in this video. I'm PVS the tutor. I'll keep seeing you in the other videos.